Our first speaker after lunch is Dr. Arun Gupta. Arun is a proven leader with extensive and progressive experience managing and leading complex global initiatives. He has a variety of certifications, all the way from Certified Six Sigma Black Belt to SAP certifications, and he has most recently worked on a lot of blockchain applications. Now, many of you who are looking at the paper may have read recently that Walmart just announced that they were accelerating blockchain implementation, particularly in the fresh fruits and vegetables. There are discussions regarding IBM and Maersk. So there's a lot of attention focused on blockchains of various types and how to leverage them to improve competitiveness. So without further ado, Arun Gupta.
So thank you. I will enjoy talking to you all about blockchain. There was some great conversations earlier using IoT, using advanced analytics. And a lot of that can be used in the blockchain. And when I say used, whatever goes into the blockchain can be made very good use of in IoT or in analytics. So first thing I'll talk about is, okay. So I give you a use case about blockchain. Better stand here. I'll give you a use case about blockchain, what happened before and after the blockchain. Then I'll talk about what a blockchain is, why is it important, how does it work, what issues is it trying to solve, and when should I use blockchain? There were some conversations I had earlier where it was like, okay, this company wants to do blockchain, but the use case they gave me was not really well suited for blockchain. So I'll give you a simple decision tree, and once you go through that tree and you decide you need to use blockchain, what type of blockchain? And finally, some use cases in supply chain, in IoT, and agriculture. How many of you have heard of Bitcoin? Bitcoin is the first example of blockchain. With the success of Bitcoin came other things similar to Bitcoin, like Ethereum. And as those things started proliferating, people were looking for, technology companies, IBM included, were looking for other use cases. So here's an example of one of the first examples of blockchain use in the government. So everybody know of this country called Estonia, right? Small company got into trouble in the sense they lost track of all their people when the Soviet Union separated. They took all the paperwork, so these people didn't know who was an Estonian citizen, who was not. This is what they had earlier, a passport which helped the people move between the EU countries, helped the people go out of the country, outside Europe. Also helped as a basic identification for certain transactions. They got into the blockchain in 2014, and they started this initiative called e-identity. This is what they wanted to do here was use this e-identity for all transactions, private or government. So here are some things that they did with this. Pretty strong security on this. I'll give you a story of it once I go through this. But this card or this document was a form identification of the person. You could use that to cast your vote. You could use that to perform financial transactions. You could use that as a debit for a bus ticket. Anything where currency was involved, anything where exchange of money was involved or transactions were involved, they could use this. Now the story was last year, 2017, yeah. Somebody hacked into their system. So they had to step back and put in a little more security into their system. And it's not been hacked since then. We'll see. So what is a blockchain? The first line is basically the short sentence of what a blockchain is. It is an immutable distributed ledger. Everybody know what a ledger is? It's basically one of those, I want to say 18th century, book where people kept record of all their transactions. So think about a group in UK wanting to ship material to France. There was a ledger in UK, I shipped so much. There was a ledger in France once they received it. Okay, that was a single entry ledger. Then came the dual entry ledger. So somebody shipping material goes into accounts payable, cuts on inventory, and multiple, I'm not an accountant, so multiple transactions happen there. Now we have a triple entry ledger system where you have the dual entry for sure, but the third is it's now distributed across multiple nodes. So I have this copy of my ledger distributed across all the nodes in my blockchain. That's the distributed ledger part of it. The immutable part makes it really important. Immutability means once you put something on a node and it is, you've reached a consensus that it is good data or good transaction, it cannot be changed. It cannot be changed. And I'll show you a real demo of what happens when you try to change it. Well, actually, let me put it this way. It can be changed, but it breaks the blockchain. Okay, I'll show you a real example of that. Basically, it's a technology for untrusted parties. When you first get into a transaction with somebody on the other side of the world, how much do you trust them? When you first get into exchanging money or exchanging this cryptocurrency called Bitcoin, do you know the party on the other end that you are buying or selling your Bitcoin to? You don't. So how do you ensure that you are safe in your transaction? Basically, what happens in blockchain is the consensus-based mechanism, at least in the financial aspect of it, asks for a 51% consensus. Now, Bitcoin, 30,000 plus nodes, 51% is more than 15,000 nodes. So 15,000 people have to agree that this transaction happened. Those people who work on agreeing or making this consensus, they're called miners. They will try and get some sort of a hash code, and I'll get a little more into hash code, but they will try and get some sort of code that validates those transactions. And the first person who comes up with that gets a Bitcoin for doing all the work to make it happen. That has been, until recently, a very lucrative business. You can make a lot of money mining for Bitcoin. But with the number of hash codes that are available reducing quickly, it becomes harder and harder to find a hash code. And with that, it takes a lot more computing power to generate a right hash code. Satya in the morning talked about GPUs. These things are thousands of GPUs that the miners use. 80% of the miners are based in China. And that's something that blockchain adopters were a little concerned about. So they are going towards a different mechanism. We'll talk a little bit about that. Efficient process at lower costs. So when you look at contracts, so how do contracts work today? A company's lawyer works with the other company's lawyer, and they basically come up with something that says, this is what I'm going to do, this is what you're going to get. Okay? A smart contract encompasses those and puts it in an electronic form, but the value there is, because it is a code, a piece of software, it's always done the same way every time. Once you put a smart contract in, it falls into the immutability, so it cannot be changed. If you have another contract, or if you want to make a change to that contract, you will redo your components of the blockchain where that contract was involved. Okay? Rather than actually go through the contract each time to see, okay, did they meet the contract, did they not meet the contract, the smart contract eliminates the need for that. How much time and how much money does your company spend in validating and verifying transactions according to contract? Lot? Less? None? Anybody say none here? So the other way this thing becomes efficient is everything is secure. So if I get on blockchain, I'm not showing everybody myself as Arun Gupta. All I'm showing is a digital ID, my digital ID. Nobody knows who I am. Similarly, when you start talking about products, let's say a PC or an engine, you can put a digital ID to an engine. Nobody knows that it is an engine other than the person who's creating it and the person who's receiving it. So there was a concern yesterday, somebody was telling me about, I don't want my competition to see what I'm shipping, how much I'm shipping. You don't see anything. All you see is a bunch of numbers. Okay? So it makes the things secure and and private. So why is it important? So any transaction that requires consensus or where immutability plays a role, or you want a provenance, you want to do a end-to-end life cycle visibility, you will use blockchain. Blockchain will be important in those things. In the supply chain, or in the pharmaceutical example, what you're looking at is you want to have a genealogy of from when the raw material came into the pharmaceutical manufacturing facility to the time this thing was dispensed to a consumer. Perfect example for blockchain. Okay? And the demo that I will show you the provenance a little bit. Okay? It's a very small, contrived example, and it doesn't talk about supply chain, doesn't talk about IoT, doesn't talk about agriculture or anything like that, but it shows you the provenance of the conversation that I'm having. this next thing, update-only capability. So typically today, databases, whether they are distributed databases or whether they are centralized databases, they have this capability of what is called as CRUD. Okay, create, read, update, and delete. You can do all those 4 things on current databases. But in an update only, the only thing you can do is read and update. If you cannot, sorry. Yeah. If you cannot delete, I'm making a mistake here. Create, read, update. So this has to read as create only. Okay, I will update this slide. It is create only. So you can create a transaction and you can read a transaction. You cannot update. You cannot delete. Okay? And the provenance basically gives you the visibility into the entire history of that transaction. So think about the scenario where I am placing an order for 10 engines. When I put that on the blockchain, I cannot say I ordered only 9 or I ordered 15. If I do that, it breaks the blockchain. When the engine manufacturer comes back with to me with 10 engines or 9 engines and says I shipped 9 engines, I know that the manufacturer owes me 1 more. Or if the engine manufacturer ships me 12, I know I did not need the extra 2. I can send those back to the engine manufacturer. Manufacturer may say, no, you ordered 12. There's my provenance that says no. Okay? Full visibility, full life cycle. So what else can blockchain do? I talked about smart contracts. Basically, because these are encoded, one way of doing things for that contract. Secure and private transactions and transparency. Now, you will see a theme here. There's a lot of repetition because these are the important things in blockchain. I came across this cartoon. I thought it would be good to put up here. But okay. So when you use blockchain, there are 3 different types of transactions that happen in blockchain. A single party reporting an event. So think about a farmer sowing seeds. The farmer sows seeds and puts it in the blockchain. Nobody else has to know about it. I mean, nobody else has to validate that the farmer sowed seeds. Once it goes in the blockchain, the person who's going to put fertilizers comes and put fertilizer. That person or that company goes to the blockchain and says, I fertilize this field. Again, a single event, single party, nobody else has to give any consensus there. So that's the first one and the most simple one. The second one is 2 parties involved, but there's no financial transactions. So when I go to a physician and the physician does a work upon me and comes back with medical notes, they put it on the blockchain and I agree. So there's a consensus there. That is the second type of blockchain transaction. Third type is 2 parties involved, and there is monetary involvement. So anything that you do with Bitcoin or Ethereum, that's all the third part. 2-party finance involved. All right? As you go from top to bottom, the complexity increases. So there's a lot, this two-party with currency exchange is a lot more complex than the single party. So how does blockchain work? I'll give you an example, the most complex one, which is two-party where there's currency involved. So, let's see. I don't know if this is showing up there. No. All right, so on the top left, you have two people, A and B. A wants to give currency, Bitcoin currency to B. You go through the consensus mechanism. Then you go through the immutability once consensus is reached. And then you go through the provenance. So the full transaction history for that Bitcoin will show up here. Okay? So I'll quickly go through some of the issues that blockchain will address. You're talking about efficiency, you're talking about cost reduction. In the supply chain, there are a lot of intermediaries. And not just supply chain, I think even in the medical industry, there's a lot of intermediaries. You won't have a need for many of them, okay? Vulnerability. Now, if you have a central system, that is vulnerable to fraud, to cyber attacks, to mistakes. In the blockchain, that gets eliminated. The advanced encryption that's available in blockchain will give you the security. And I talked about the identity. I have a unique identity on the blockchain. An engine will have a unique identity. I talked about trust. So multiple parties, if they're using blockchain and there is consensus, then there is trust. And every step I can go through the provenance and get through the steps. Let me quickly jump to a demo here. All right, I did this in the break, basically, and you can do this too. There is a URL called blockchaindemo.io. So when the blockchain first starts, it goes into this thing called the Genesis block. This is block 0. This is the start of the blockchain. When a Genesis block is created, it has some data here. And in here, the data is welcome to blockchain demo 2.0. And that data will generate a hash, which is shown in the green. Okay, when you look at the hash, there is a level of complexity in the hash. This level of complexity shows that the first 3 characters have to be a 0. Bitcoin has a much higher level of complexity. First 18 characters have to be 0. So you are shrinking the hash functions that you can get out here. What I did was I added some information in my some data in my next block. It says it's a wonderful day at Purdue. And now I just see that it is spelled incorrectly. I'm going to make a change. You know, see everything turned red. I just broke the chain. Because this, I made a change to the data, the hash changed. The hash changed, my subsequent block doesn't now tie up with my current block. Okay? So it does not, it allows you to make the change, but then it says, okay, somebody messed up here. Okay? And I am going to make another change. I don't remember how I spelled it. But everything downstream of that turned red. Okay? So that's that's what you get in blockchain in terms of uh, immutability, in terms of provenance. You see the provenance here. I got all those four blocks from block 0 to block 3. Okay? And I don't have much time left, but so these are some examples of where blockchain can be used. I did some Google searches and put them here. I cannot use blockchain here. I cannot use blockchain here, or here, or here, or here. Okay? So there are many places where you cannot use blockchain. But I can use it here, 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 and here. Some examples of where I can use. Important slide. Should I use a blockchain, and what type of blockchain should I use? So the thing here is, if you as you follow this decision tree, do I have to save the data? Almost everybody has to save data. Okay? Are there multiple people writing to the data? Oftentimes that is the case. Are the writers untrusted and or unknown? If they are, then you will potentially need blockchain. If they're not, you can stop right there. Okay? Do I have or do I need to rely on a trusted third party? If I have to rely on a trusted third party, and that's not a mistake, you don't need a blockchain. The trusted third party is actually going to be doing it for you. But if you don't rely on a trusted third party, then you ask your question, I don't have a need for access control. Immutability is more important than efficiency, and transactions need to be more or less public. If I say yes to all those questions, then I need a public blockchain similar to Bitcoin and Ethereum. If you say no to those questions, then you ask yourself next set of questions. Is there a consensus required? Is there a party consensus required? If there is a party consensus required, then I go to consortium. If not, then I go to private. Okay? So you should have these slides available to you, but this is one of the important slides just for your decision-making process. So in supply chain, talked about fraud and errors, and there are many use cases in supply chain. With blockchain and IoT, you can build your blocks with the data coming from IoT. Okay? You can use this in the supply chain. You can use this in agriculture. I gave you examples of putting or planting the seeds and fertilizing. If you are an organic farmer, that becomes more important. You have to show. All right? Okay, I'm going to run through this. We'll talk about questions in the panel. Okay.